In this video, I'm going to be verifying an identity. And what that really means is this. An identity is an equation, so it involves an equal sign. It's an equation that is true for any value. I put an x here. Really, I should be saying for any value of theta. No matter what angle we choose, is this stuff on the left the same thing as the stuff on the right? Now, proving something's not an identity is pretty easy. All you have to do is pick an angle, pick a random angle like 37 degrees, and plug it in and see if the left side ends up giving you the same value as the right side. If you use 37 degrees for theta, that would be one way to prove that an identity is not, or that something is not an identity. Verifying that something is an identity takes a little bit more work, and the process goes like this. We're going to start with the complicated side, always the complicated side. And we're going to try to whittle this down. We're going to try to simplify this, just like I did in the last example. And we're going to simplify it, and if we do it right, if it's an identity, we should get cosecant theta whenever we're done. And so really, this is almost the exact same as a simplified problem. Well, let's see here. If I have two fractions, and I want to get rid of the fraction, which is apparently what I've done over here. If I want to get rid of the fraction, I think the first step is going to be that I need to combine those. I need to get a common denominator. And the common denominator in this problem is going to be sine theta times 1 plus cosine theta. The reason I chose that is because just like you would do with numbers, you know, if I was going to, I should do this off to the side, if I told you to add like 4/7 and 3/5, and you're like, shoot, what do 7 and 5 have in common? Well, you know what, I'm just going to make it 35. It's the easiest thing I can think of, so I'm going to use 7 times 5. Well, the same thing here. I don't really know what the common denominator is. Maybe they go into something small, like maybe those go into something smaller than 35. Maybe they don't. So the easiest way is just to multiply them together. So I'm going to say sine times 1 plus cosine theta. Now, whenever you did this, whenever you change these into 35ths, you wouldn't just say 4/35 plus 3/35. That wouldn't make any sense at all. That's absolutely incorrect. You need to change the values on top, right? So you would have said, I'm going to take 5 times this one, I'm going to take 7 times this one. We're going to do kind of the same process here. See, I have the 1 plus cosine on the bottom here. But in order to get up to the common denominator of sine theta 1 plus cosine theta, it looks like I'm missing the sine theta, aren't I? So I need to take this sine theta, and I need to multiply it by sine theta to get it up to the common denominator. So there's the first term. The second term, I take a look at this, and it looks like it already has the sine theta, but it needs the 1 plus cosine theta. So I'm going to take this cosine theta, and I'm going to multiply it times 1 plus cosine theta. There I go. I have my one fraction. This is just the left-hand side. I'm going to go ahead and say that's equal to cosecant theta. That's what I'm trying to figure out. Now it's time to do a little distributive property on the top. I have sine times sine, that gives me sine squared. So I have sine squared theta. I'm going to distribute out the cosine here. So I have cosine theta times 1, and I have cosine theta times cosine theta, which is cosine squared theta. That is over. I'm not going to worry about the bottom for now. Let's worry about the top first. One thing at a time. I've got that all over the denominator. Now the nice thing is this. If you remember, sine squared plus cosine squared. Well, I have an identity for that, right? See, I know that the sine squared theta plus cosine squared of theta is equal to 1. So I'm going to take this sine squared and cosine squared and I'm going to replace those. I'm going to take these out and say, you know what, that's just 1. So really the top then becomes 1 plus cosine theta. And the bottom is still sine theta times 1 plus cosine theta. And that's pretty convenient because now you will see that the 1 plus cosine cancels out of the top and the bottom. And I'm really left with 1 over sine theta on the left. Remember, we're trying to prove that this is equal to cosecant theta. So I'm going to go ahead and write that on the right. This is my proof. And now conveniently you find out, and this should be the last step of any proof, you find out that 1 over the sine of theta, or if you know your reciprocal identities, that is cosecant theta. Put a little check mark with the circle. We are done. There is the proof. Now the proof is not the answer. Let me be clear about this. The proof is not this last line of work, because if it is an identity, everybody should have the exact same last line of work. It should say cosecant equals cosecant. The proof, the verification, where you're going to get points if you're doing this for a homework problem in your math class, is all the stuff that comes above it, showing step by step how you progress down to cosecant theta equals cosecant theta. Alright, so I'm going to break this up just to make the video shorter. I'll create another video here in a second that does this problem, which should be a lot the same.